All right, good morning, everybody. Let's get ready for the Test 9 review. Let's see what we got coming up. So, kind of an oldie but a goodie here, but I'm still having some people making mistakes, primarily just because they're going too fast and they're silly mistakes. You got a couple of rules here. First rule is do the work in parentheses first. So the first thing I'm going to tackle is getting an answer for these 3 digits. But a few people are still making mistakes here. If one number has a dollar sign and a decimal point, they all must be written that way. So we would start off doing the work in parentheses first. So I have $3.55. But then when I add this $10 to it, I don't want to put the $10 over here. I have to write it with a dollar sign and a decimal point, right? Because $10 is a lot different than 10 cents if I lined it up over here to the right. And then 72 cents, correct? So then I would have to go and find out what is my answer for these 3 digits. $3.55 plus $10 plus 72 cents. Let's get ready. 5 plus 0 plus 2. Hey, that's 7. 5 plus 0 plus 7. That's got to be 12. I write down my 2. I carry my 1. Very nice, neat, and carefully. 1 plus 3 plus 0 plus 0. That's going to give us 4. And 1 plus nothing is 1. So the other silly mistake I see happening is that people will sometimes think, hey, I'm done. I got the answer. I did a lot of math. But they're forgetting about the second half of the problem. So now I have $15. And when I write that $15, I have to write it with a dollar sign and a decimal point, right? So you're going to have $15, and now I have to go and subtract $14.27. The biggest mistake I see on these is people being sloppy, silly, or messy. Not that there's a lot of math that people are struggling with on this concept. All right, so now that I have everything written with dollar signs and decimal points, let's start subtracting. 0 minus 7, can you do it? No, so you go to your neighbor. He says, hey man, I'm broke too. I got 0. So you go to the next neighbor. You have a 5, cross out the 4, and take the extra 3 seconds to write the number on top of it. Pay the neighbor 1. Now the neighbor has 10. He says, hey, I got 10. I can pay you 1. So 10 becomes the 9, correct? And now you can pay the 10. Again, don't cross that out and write 9, because who's he paying? Nobody. So now we're ready to subtract. We have 10 minus 7. Hey, that's 3. 9 minus 2, that's going to give us 7. Decimal point comes straight down, right? And 4 minus 4 is 0. 1 minus 1, that's also 0, but we don't really have to start it with 2 zeros. Nothing is the same as 0 for an answer of 73 cents. Check out this one, the old function tables that people still sometimes struggle with. It's all about figuring out your arrows and what's going on. So it's going to say, what does the function do to each in number? Our in numbers are 2, 6, and 12. If you put in a 2, they're saying out comes a 1. If you're putting in a 6, they're saying out comes a 3. If you're putting in a 12, they're saying out comes 6. What is going on with each of these? Are we subtracting by 9? Well, 12 minus, no, I don't think we're subtracting by 9. No way. Are we multiplying by 2? Sometimes people get confused if they don't write in the arrows. Does 2 times 2 equal 1? No, it does not. It can't be B. Does it divide by 4? Is 2 divided by 4 1? No way. What's really going on here is it's dividing by 2 because 2 divided by 2 is 1. 6 divided by 2 is 3. And 12 divided by 2 is 6. So now that we know that, let's take a look here. If 8 is used as the in number, what will be the out number? Same concept, we just decided the rule was divide by 2. We said that on the other page, right? So 8 divided by 2, that's going to give us a 4, right? Use the rule from the first one to figure out the second one. Check this out, and I see some people struggling because our rulers that we have in our classroom are not all the same, and some of our rulers have a tiny little edge over here, and people want to always line up to the edge. Well, you do that on some rulers if the edge is 0, but some of our rulers have a 0 over here. Make sure you always start at 0. The other thing I want to point out is it says use an inch ruler to measure the length of this segment to the nearest eighth of an inch. Well, if you look at each one of these segments here, we actually have 16 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If you are doing ace, every other line, if you see it where it's a little bit longer than the short ones, every other line is an eighth. So we're past the whole number 2, so for sure I know it's 2, but every other line, 1/8, 2/8, that would be 2 3/8, right? So a couple of things to be aware of. If you have one of those rulers that 0's not on the end, make sure you line up at the 0. Check out this one. What mixed number is half of 45? And we've been saying this for months now. If the numerator is 1, divide by the denominator. But Mr. Hines, they might say, I don't have a fraction. Well, half. That's the same as 1/2, right? So if you can't do this in your head, you better go and set up in the divide box 45, and I'm going to be dividing by the denominator, by 2. 2 divides into 4 2 whole times, multiplies back for 4. It's going to subtract for 0, and I'm going to bring down my 5, am I not? 5 divided by 2, that's going to go in there 2 whole times, multiply back for 4, and it's going to subtract for 1. But here's the kick. I'm not going to say 22 remainder 1 because they wanted us to write it as a mixed number. So remember, the remainder, your remainder of 1 here, that's your numerator. Your divisor is the denominator. The divisor here is 2, so use that as the denominator. So if they want it as a mixed number, it's 22 1/2. Coming at you from lesson 45, the question is being asked, which of these quadrilaterals, a quadrilateral is nothing more than a four-sided polygon, so which one of these quadrilaterals below is not a parallelogram? Now, I also want to advise that whatever we see on the upcoming test might not look exactly like this. It might not be asking about a parallelogram, but you can turn to lesson 45. You can look up either of these terms in your glossary, right? And if we looked up the word parallelogram, it will tell you it's a quadrilateral with two pairs of parallel sides. So if we had two pairs of parallel sides, that would mean this side is parallel with this side. That's one pair. And then this side is parallel with the other side. Two pairs. So let's see. This side's parallel with this side. I get that. And this side is looking like it's parallel with this side here. So that guy's got to be a parallelogram. This side here is parallel with this side here. This side looks like it's parallel with this side. Hey, he's got to be a parallelogram. This side is parallel to this side, but look what we got going on here. This side is not parallel to this side. Parallel means that they would never, ever, ever meet, no matter how far they extended. And guess what? They're gonna meet, right? So, which one's not a parallelogram? It's our friend the trapezoid here. Check out this guy. It's telling you which mixed number, and remember, a mixed number is a fraction and a whole number, names the number of shaded. Make sure you don't trip over shaded or not shaded circles below. So looks to me like this whole circle here is shaded. There's your whole number. One whole circle. And this appears to be cut into four equal pieces, right? There's a fourth. This guy over here is a fourth. This guy down here is going to be one more fourth. And lastly over here, he's also a fourth. So how many of these fourths are shaded? Looks to me like you have 1, 2, 3 of them, right? So if you needed to write it as a mixed number, that is 1 and 3/4. Check out this one. They are asking you in the directions to use short division. I'm going to say this. Go ahead and use short division if you're comfortable with it. But if you'd rather set it up in long division form, you go right ahead. All I care about is that you can actually divide. So if you are going to use short division, here's two little pieces of advice. Leave room between the digits and the dividend. Don't cram it so the numbers are touching, because you need this space to write in. And if you're using short division, that means you multiply back and subtract in your head. The division rules are the same. I'm going to start dividing into 12. 8 divides into 12 one whole time. I'm going to make sure I write them nice and neat above there, right? Multiply back in your head, that's 8. 12 minus 8, that's 4. So write it right next to the next digit. So now I'm going to go and divide into 40. 40 divided by 8, hey, that's got to be 5. Multiply back 40 and subtract 40 minus 40, that's 0. The big mistake some kids will make They'll say, oh, it goes in there 15 times. But remember, you need a quotient digit here, you need a quotient digit here, and you need a quotient digit here. So how many times is 8 going to divide into 0? That answer is 0. So your final answer is not 15. It's really 150. So I really didn't think I was going to have to put this one on a test review, but I had some people last time out give me a remainder on a money problem, so I threw this on there just to remind you there are no remainders on money problems. So let's start dividing this guy out. I'm going to start right here. 31 divided by 4 looks to me like it's going to go in there 7 times. Multiply it back for 28. I believe it's going to subtract for 3. Bring down your next number, which is the 6. Park it right next to the 3. And 36 divided by 4, that's 9. Writing them nice and neat above that digit. Multiply them back for 36 and subtract them for 0. Bring down your next digit, that 4, and you're going to park it right here. 4 divides into 4 one whole time, multiplies back for 4, and he's going to subtract for 0 because he's a money problem and there's no remainders in money problem. Also, on a test, if you forget your dollar sign and decimal point, that is going to be half wrong. You want to make sure you have your dollar sign and decimal point written down in your answer. So check out this one. You actually aren't going to need a ruler, but I figured I'd put it on the same way. If you are using a ruler, make sure you start at 0. But here's the actual question. A line is 60 millimeters long. How many centimeters long is it? And if you remember, these numbers here are centimeters. These little tiny ones are your millimeters. And if you counted, there's actually 10 millimeters here. This would be 20 millimeters here. If you counted 10 more, that would be 30 millimeters, 40 millimeters, 50 millimeters. Here's 60 millimeters. So when you're trying to go from millimeters to centimeters, all you really have to do is divide by 10. So how many centimeters is it? It's 6. Check out this guy. 3 nickels makes up what percent of a dollar? And when we're talking dollars, the percent is the same as the cents. That works if you're talking about $1, $1, because 100% of the dollar has 100 cents on it. So let's think about how many cents is 3 nickels, right? Well, 3 nickels, Mr. Hines, that's 15 cents. So the percent is the same as the cents. So what percent does it make? It makes up 15% if it's 15 cents. Check out this one. I don't care if the book tells you to draw a picture. Personally, cross multiplication works the best. Take the denominator of one number, multiply it out till you get to the numerator of another number. 3 times 1, hey, that's 3. And then go the other way. Take the denominator of the other number, multiply it up to the numerator of the other one. 4 times 1 is 4. Now use your comparison to figure out what's bigger, 4 or 3. Crocodile's mouth is opening up to the 4, so 1/3 is greater than 1/4. Check out this guy. Remember to dangle the 0. I got people when they're trying to set these guys up, they're putting them over here, and you technically don't know how to multiply that way yet. So all we have at our disposal, at least for the next few lessons, is the old dangle the 0 trick. And when you dangle the 0, don't even worry about them to start off with. Here's how we're multiplying. 5 times 2, that's 10. Write down my 0, carry my 1. 5 times 7 is 35, plus 1 more is 36. So I'm going to write down my 6. I'm going to carry my 3. Then I'm going to go 5 times 4 is 20, plus 3 more. Yeah, that's 23. Don't put in your $sign and decimal point yet, because now we have to take care of our dangled 0, right? So bring the 0 straight down, and now is the time to put in your decimal point. With 2 places, not 3 like a comma. Okay, check out this guy. I still have some people struggling from time to time with it. Remember, you cannot multiply 3 numbers at once. You can only multiply 2 numbers, get a product. 5 times 5 is 25. And then once you have that product of the 2, then you multiply it out by the third. 25 times 7. This problem is actually saying. So it's not too tough if you take it step by step. 7 times 5 is 35. I'm going to write down my 5. I'm going to carry my 3, right? Then I'm going to go 7 times 2 is 14, plus 3 more. Hey, that's 17. So you got a final answer of 175. Check out this guy. The big secret here, even though you might be able to look at it right now, set the problems up and down vertically. Fractions very soon are going to get a tad more difficult, and if you don't get in this habit, you're going to start getting into trouble very, very quickly. So set them up and down vertically. Take care of the fraction side first. 4/10. Take away 2/10. All you do is subtract the numerators. 4 minus 2, yeah, that's 2. The denominator stays the same, right? I had 4/10, I took away 2/10, and I have 2/10 left over. Now take care of your whole number side. 3 minus 1, that's going to give us 2 for a final answer of 2 and 2/10. This is kind of an interesting one as well, and I'll show you what I mean. Set the problems up and down. 3/5 minus another 3/5. Well, if I had 3/5 and then I took away 3/5, you're technically right. You might have 0/5, but if somebody didn't eat any pizza, you wouldn't say, I ate 0/5 of that pizza. You'd say, I ate 0. If the numerator is 0, don't bother writing the denominator. It's plain old 0. Check out this guy. Marissa has 7 rolls of nickels. 1, 2, 3, 4, 5, 6, 7. Each roll has 40 nickels in it. How many nickels does she have? Well, she has 40 here. And if she would have 40 more here, and she would have 40 more there, and so on. And so on, and so on, and so on, right? So I could go ahead and I could add these. I could go ahead and add 47 times. But wouldn't it make a whole lot more sense just to take your 40 and times it by 7? And if you're really on top of the game, you can do the little cover up the zero trick. So what's 7 times 4? Well, that's 28. So 7 times 40 has to be 280, right? And that is the end. Remember, double check your questions and the answers. If you are getting A's on your daily work assignments, why are you getting a B on the test? Slow down and double check.